Our goal for this lesson is that we can solve problems that involve percents. So let's actually start with some, vocabulary. Where it says translate it here in the box, we have these two options, these two examples. 15% of what number is 4.8, and what number is 20% of 50. So we keep seeing some of these words again. So off to the left here, what it says. So let's start with the easiest thing. If it gives us just a plain number, we're going to leave that number the same. So for example, this 4.8 is going to stay 4.8, and this 50 is going to stay 50. Okay, another thing we have is we see the word of. So we have the word of, 15% of what number, and what number is 20% of 50. So if we see the word of, that means we are going to times them or multiply. And we're going to use a dot symbol for multiply. I can write that in here too, multiply. Times, multiply, whichever one you want to write in there. And there's a reason why we're going to use that dot for multiplying. Our next one is we see that it keeps saying what number, what number. Sometimes it might say what percent, and that is a little bit different also. So if we see what number, well, when we don't know a value, we use a variable, and we're going to typically use x. You don't have to use x. You can use a, b, x, y. It doesn't really make a difference. We try to avoid using certain ones, like a lowercase l looks like a 1, or an o looks like a 0. So we tend to be careful with what we use, but otherwise we can use whatever number. You can use n for number if you'd like to. Another one is the word is. I see the word is in there. The word is 48. What number is 20? If I see the word is, that means equals. And then wherever I see, for my last one, wherever I see like this 15% or 20%, or if it says what percent, so if we're looking at a percent, we need to make sure we turn that into its decimal value to calculate with it. So I would have to turn this 15% into its decimal, and we could do that in just a second. So let's translate these two examples, A and B, now that we have these words. So 15%, so the percent turns into a decimal, that's 0.15. And we can look at an example over here. Percent to decimal. We're going to move the decimal 2 places. So 15%, when there is no decimal, there's 1 at the end, and you move it 2 places to the left, becomes 0.15. Of means times. What number? We don't know something, we use a variable. Is means equals. 4.8 stays 4.8. Now let's translate B. What number? So our unknown, we use our variable. Actually, just for an extra example, let's use n for our variable this time, because it really doesn't make a difference. Is equals 20%. Remember, there's a decimal at the end. We move that 2 places, becomes 0.20. Of means times 50. And if you want to, in this case, we can use the x for times, since we use the n for a variable. We just don't want to get the variable x confused with the x for multiplication. Okay, so now that we've translated these, let's work on solving them. And to do that, we're going to use inverse, which means opposite operations. So opposite operations would be plus and minus are opposites, multiplying and dividing are opposites. So that's what it means by opposite operations. So I'm just going to copy down what we found for A. That was 0.15 times x equals 4.8. So to use inverse or opposite operations, we look at what are we doing to our variable. And we're taking 0.15 times x. So our variable, x, is being multiplied by 0.58. And we just said the opposite of multiplying is to divide. So then I'm going to do the opposite on both sides. Instead of multiplying by 0.15, I'm going to divide by 0.15. And notice I'm using that fraction bar to mean divide. And then in my calculator, because these are opposites, these are going to cancel each other out. And in my calculator, I'm just going to put in 4.8 divided by 0.15, and then we should get 32. And then let's try the same for B. So we had n equals 0.20 times 50. This one's actually a little bit easier. If we notice on this one, our n, our variable, is already all by itself. So I don't actually have to use inverse operations. It's mostly solved for me. It's telling me I'm going to multiply 0.20 times 50. So I can just put that right in my calculator just as it is, and we should get 10. So it's not a bad idea to take your time to put those in the calculator and make sure you can get those answers. And then let's look at one other example just to make sure that we are understanding how that works. So if I translated and I ended up with, let's say, we ended up with 0.32 times x equals 40. I'm multiplying x and 0.32. So then the inverse of that, or the opposite, is to divide. I'm going to divide both sides. What was I multiplying by? I was multiplying by 0.32, so now I'm going to divide by 0.32 on both sides. So x equals, and then I would just put in my calculator that 40 divided by 0.32, and we should get 125. And then do one more example, because what we haven't seen yet is it says what percent. So what if it says what percent of 20 is 5? So let's try this last example because it's a little bit different. So what percent, we don't know. We need to return a percent to a decimal, but I don't have a number yet. So that's my unknown. My unknown, we're going to use a variable. I'm going to use a variable p to represent percent. So what percent, p, I don't know, of times 20, the number just stays a number, is means equals, and then 5, a number just stays a number. And then we look at inverse operations. So what happened to our variable? Our variable p is being multiplied by 20. The opposite of multiplying is to divide. So we divide by 20. And I do the same on both sides. And then those cancel. So our variable p equals, and then in your calculator you would type in 5 divided by 20, and we should get 0.25. Now we're almost done. This actually has one extra step, because our problem said what percent, but my answer is not written as a percent yet. So we have to take this decimal, 0.25, and write it as a percent. So we'll do like what we did here. We're going to go backwards. So we're going to move the decimal in the opposite direction 2 places. So we're going to move the decimal 1, 2, and then we get that's 25%. All right, and then the last type of problem is this percent increase, decrease. To find that, we're going to find the change. How much did the price change by? And then divide that by the original price, or the original amount. So here our original price is $28. Our sales price, it now costs $23.80. So I have to find the change. How much did that price change by? So I would want to put in my calculator $28 minus $23.80. And I would find that change is 4.2. So that goes on top. It changed by $4.20. And then we put the original on the bottom. The original price was $28. So the original price goes on the bottom. And then we're just going to divide that. So 4.2 or 4.20 divided by 28, and we get 0.15. So again, we put how much did the price change by. We divided it by the original amount, and that came from over here, our equation, or our formula. And then we're going to move the decimal because we're looking for a percent. We're looking for the percent of increase or decrease. So we're going to move that decimal 2 times, and then we get 15%. So that price went down. It was on sale 15%